I'm going to continue going through the activities that are described in Java Web Programming with Eclipse. I'm currently at the chapter Database-Driven Web Applications. In this chapter, we're going to connect to the MySQL database, and for that to work, we have to visit the MySQL website and download a driver. And let's go ahead and take a look at that. Here's Java JDBC. That's the right place to be. The Mysql Connector J is a native Java driver that converts JDBC calls into the network protocol used by MySQL database. That's in fact what we want. So let's see, how do we download this? Here we go. There's only one choice there, platform independent. That's good. Let's see, we have tar file or zip archive. They contain the same thing, even though they have different sizes. At least I think they contain the same thing. And I'm going to download the zip archive because I'm working on Windows. That's more convenient. So I'm going to copy that zip file into my standard location where I organize those sorts of things. I'll put it into its own folder. Let's see, it's MySQL Connector Java. And just to compare to how we did that, I see I have Java libraries in here. Maybe that's where I should put it actually. Let me in fact do that. Let's take a look at what's inside. Let's just open it first. So this file is going to serve two purposes. The first is it will contain the jar file, which is right there, and I'll extract that. Extract to the specified folder, that's fine. And then it will contain the source code. And this is going to be useful when we attach the source code. So this actually, I don't think we probably need this. So I think what I'm going to do, I don't think we need the source code, but we do need the this jar file. Some mistake that a lot of students make is they don't extract the jar file from the zip file, and the Tomcat is not able to load that jar file from the zip folder. So let me go ahead and put that in my Java libraries here. I don't think I'm going to need the source code for this. In fact, so I don't even need this that stuff anymore. So I'll just delete that. Alright, let's return to the web page. Now there's another library that we need. It's called, or two more libraries, JDOM and Roam. So the JDOM library, the Roam library, and the log4j library. These three libraries we need to add to the publisher application. So let's start up Eclipse. Just going to clean this up here. So as you can see, the website application has this webinf folder. The publisher application has that as well. But what we need to do is add this this lib folder. So under publisher, I will add a new folder called lib. The lib folder is where we store the Java libraries. So just highlight these. I'm going to copy. So I can do this right inside of Eclipse. And I right click on this lib folder and paste. By the way, it must be called lib. It's case sensitive. Well, maybe not on Windows, but on OS 10 and Linux, that's case sensitive, as well as the webinf. So this is a standard name. This is the specific folder that Tomcat will look for when it goes to load the libraries or the classes that are stored in those library files, those jar files. Okay, let's continue on. Now I remember, we need to configure the logger. So in the website application, we have this log4j properties file. Let's copy that and drop it in the source folder for publisher. Let's go ahead and paste that in there. We'll need to modify some of the data in here. This is good. This is rather than having it print the logging output go into website.log, let's have the logging output go into publisher.log. So that's a log file for the publisher application. And this is the here website. That's the package name of the Java classes that are used in the website application. For the publisher application, we're going to put those classes under the package name publisher. So we need to change that there. So those are two places that need changing. It's mentioned here in the book. And we need include the servlet API as in the build path. These classes are already in Tomcat's runtime class path, but they're not available to Eclipse at build time. So those have to be added, or that has to be added. Well, let's check to see if it's there. These are the reference libraries. In fact, it's already there. Servlet API.jar is in fact a reference library. And let's go forward. we need to create a servlet called newsfeed servlet. And this servlet will get the newsfeed data from the database and produce a document that's similar to this static document, news.rss, that we're using currently. So we're going to replace the static document with a dynamically generated document, one that's generated by the newsfeed servlet, which gets the data from the database. Alright, so let's go ahead and do that. So under SRC, I'm going to right click, New, Class, Newsfeed Servlet. We need to put in a package name. Let's make the package publisher.web. So we start with the name publisher, and then we'll have several sub areas. And this area is called web, and it will correspond to the controllers, actually. Okay, so let's here the superclass is going to be, does it give a suggestion here? It's a HTTP servlet. Paste that right in there. Now, this is not a fully qualified name, so if I hold down Control and press spacebar, it gives me a list of choices. I'll pick this one. This is javax.servlet.http. That's in fact what we want, not the other two. These are different classes. This is HTTP servlet request wrapper. That's not the class we want. We want HTTP servlet, which is within the namespace javax.servlet.http. So let's go ahead, double click on that. I had to do that. And yeah, we'll let the Eclipse generate method stubs for inherited abstract methods. We'll take that. There it is. Okay. So this line here gets the logger set up so that we can write into the into that log file. You'll notice that there's a build error, and we can fix that. We can use quick fix. One way to do it. No suggestions. No, that is not a way to do it. So it's under source, organize import. So we're telling Eclipse to search for a namespace that contains the selected class and present a list of possible namespaces for us to choose from. And so in fact it didn't give us a list of namespaces to choose from. There was only one, and so it went ahead and inserted this import statement for us, so that this class logger, which we're using here, is now defined. You'll see it still has this red X, meaning that there's still a build error, but if you notice there's an asterisk here. It's a build error because although we fixed the code, we didn't save the file, and the incremental builder did not run. So I just saved the file. This should in fact disappear. Oh, look at this. This is an excellent opportunity for me to explain something. This is not the right package. It's not Java util logging. This package has a class in it called logger, and this is the logging API that was added to Java after Log4j became widely used. and they use the same name for their class called logger. And the log4j package was not available in the class path when we ran that organize imports command, and so it wasn't able to find our log4j version of the logger. So this is what I'm going to do. And by the way, why is this still a build error? That's because although the core Java language now defines the logger class, that class does not contain a method called getLogger that takes a single argument like this. So I'm going to delete this. This is how you fix that. Now the problem is this log4j is not in the class path. The servlet API is in there, but log4j is not. So we need to add that. I'll go into this lib folder. There's log4j. I'm going to right click that and add that to the build path. Okay, now we'll go up to source again. Actually, I had to put the mouse somewhere in this file. Last time we right-clicked and went to source, but you can also put your cursor in the file of concern and select source from the menu up here. There's organize imports. Now at this point we added the log4j library into the build path, and so when we run organize imports, it should find two alternative implementations of a class called logger and present those two alternatives to us in a list. Let's check that. There it is. This is the new alternative org.apache.log4j.logger. Here is the logger that's a part of the namespace java.util.logging, which now comes with the core Java distribution. And so what we're using is the log4j logger. We'll select that and click finish. Once again, this this is a marker here. Something's been fixed. The file's not saved yet. We still have a build error. We save it. Build error is gone. We're in good shape. We have a warning here. It says the logger is never read locally. That's fine at this point. It's saying that, well, we created this thing, but we haven't used it, so it doesn't make much sense to even create it. But we will, in fact, use it, so that warning will disappear as we go forward. Alright, so in the newsfeed servlet, we're going to override this init method. And we can do that in two ways. We could just paste this directly in there, which is the sample code here, or else we can generate a stub for this method. That's what I'm going to try to do. Let's generate a stub, and let's do that in here. So I'm going to just make that a little larger, and I'll go source. So I put my cursor where I want the stub to be generated. The stub is it's a declaration or definition of a function, but the function doesn't contain any logic in it. It's just the body, just the shell of the function. It's an aid. It's a programming aid. Make sure we get the syntax correct and all that. So let's go ahead and do this. So I go to source, and we'll need to find this. Here's generate getters and setters. Here it is. Override, implement methods, and these are the methods inherited from HTTP servlet. Now HTTP servlet inherits from generic servlet, and these are the methods are available through generic servlet. Generic servlet implements or extends is the better word. Generic servlet extends HTTP servlet. Object extends generic servlet. These are the functions that our class has access to or inherits through this hierarchy of inheritance. So in fact, I believe what we want is not in here. So this init method is not available to us through our direct parent HTTP servlet. As you can see, there's no init method in there. That means the init method comes from a higher source. It comes from our parent's parent generic servlet. Let's open that up. And notice there's two versions of init. And this init method, when it runs, Tomcat passes in something called a servlet config object, and that's going to be useful to us. So that's the method that we would like to override. And there it is. There's some annotation. This @override. This is very useful to leave in there. It tells Eclipse that that this method is meant to override a parent method. So if it's good practice to leave that in there. If we take it out, it's fine. But it helps us in general to catch errors. If we think we're overriding something and we're not, then we'll get a warning with this method, a warning or perhaps an error. Let's see. Actually, let's check that. Let's check that hypothesis. So we get a clean build here, although there's still a warning related to the logger. Let's change the function signature so that we're not actually overriding anything from the parent. There's no initx. Okay, so let's go ahead and put that in there. And you'll see that it's actually a compilation error. And that's because of this this annotation. Let's take the annotation out, and you'll see that the compilation error now goes away. So it in fact generates an error. So we're telling the system that this function is meant to override an inherited function. So that's a convenience. As you can see, that's easy. That's useful for catching bugs. Now, what's interesting is this mechanism was added to Java relatively recently, and C# is did a lot of learning. The people that implemented C# made use of some of the improvements that were made to the Java language, as well as ideas from other areas as well. And so when you declare a function in C# that overrides a parent, that in fact it's part of the function declaration. I think it maybe, I don't remember, it's either override or it's new or something like that. I don't remember the details. Okay, let's so here we have this. Now I know that we don't need this init method, so I'm going to take that out. But you might want to leave that in there in general when you do this. And here's the method implementation. Oops, there we go. I'm just going to clean that up a little bit. What's this cleanup format? Try that. Just that just normalized the indentation for me. Also, I like this better. I'm just going to put a little new line there. And so here it is, where this command, as described in the book, results in having this class loaded, which triggers a static execution block inside the driver class that initializes for making database connections. So that's what we need there. All right, let's continue on. course, you need to read all of this, but since I wrote this, I don't need to spend as much time reading it. Alright, so here's a do-get method. Once again, this should be declared as overridden, and I will maybe need to change that in my book. This time I won't generate the method stub. I'll just paste that code in there. And just want to add this annotation. That's what it's called, annotation. The override annotation here. Now I could manually fix the indentation, but as I showed you last time, Eclipse will do that for us. We do source format, which is Control-Shift-F. Let me try that, Control-Shift-F. So it's Control-Shift-F. Okay, that's convenient. Things are lined up nicely now. And but we have some issues here. HTTP servlet request cannot be resolved to a type. Here's a quick fix. Let's go ahead and import that. See, when I selected that, it added this. Actually, it may have added these as well. Not sure where those came from. And same issue with these other ones. Let's see if we can get that quick fix again. Alright, I don't see it there. Quick fix. There it is. Import. That's that. Save that. IO exception. That one comes up this time. Import IO exception. It's good. Now now this quick fix is not giving me what I want. Actually, maybe fix project setup is the way to do it. I've never done this before. Let me try it this time. Look at this. The following proposals have been found to fix the unresolvable reference to SYN feed. Add the archive row-1.jar to the build path of publisher. That's in fact exactly what we want to do. That SYN feed, I think it automatically added, there it is, an import statement for that SYN feed class. So this is also part of that package. Let's go ahead and get that in there. I've never seen that that help before. That's interesting. Here's list. That's a standard Java class. Let's go ahead and I'm just going to hover over that. Import list from the Java AWT. That is not right. It should be list from the java.util, a package. SYN entry. Import from this. There's only one package available there. Array list. Let's import that one. Connection. Oh, it's there. Connection is a part of the java.sql. We didn't need to add when we added the connector J library to Tomcat's runtime class path, which we actually didn't do yet. That was a mistake. I forgot to do that. When we go to add that, that JDBC or connector J jar file will not be automatically added to the build path in Eclipse. On the other hand, we don't need it there because that library contains classes that override classes that are defined inside of the core Java API. And this is part of that. Java.sql is a package that's a part of the core Java API, which contains a definition or declaration of this connection class, and the JDBC or the connector J jar file that we downloaded just a moment ago subclasses this connection class and implements the functionality within it that's required for dealing with the MySQL database. So let's go ahead and pick that. And the driver manager, it's the same thing. Import driver manager. This is correct. Statement. There's an awful lot of this to do. Import statement. Java beans. No. Import statement. Java.sql. Yes. Same with the result set. If they give us a choice there. Java result. Import Java result set. Oh, sorry. Import result set from Java.sql. That is correct. And incredible, we still have more to do here. Import sind entry impl from there, that's good. More to go. This is one big job here. SQL exception, that's what we want. And writer is import writer from Java IO, that is wait a second here. That's right. In fact, it is an instance of print writer, but this is the parent class. That's good enough for our purpose. Send feed output. That looks good. Feed exception. And let's see if we get a clean build. There it is. Now I forgot to finish the job over here under where is it? Java libraries. I'm going to copy that. So I'm going to copy the MySQL Connector Java jar file and put it where I need it, which is in the following location inside my folder that contains the Apache Tomcat distribution. And we'll go into lib and just drop it right in there. Now, by dropping a jar file in this folder, we're telling Tomcat to make the classes and other objects within the jar file available to the Tomcat container for loading, and we will configure Tomcat to in fact load some of the classes from that file. Okay, so that one is done. Let's go back to where we are. Well, this is this list of items is not sufficient for this. Let's keep moving. Explanation that you should read. There's a web XML file. Web XML file will contain this contents. Let's take a look at that. That would be in here. Just going to override that, or paste over top of it rather. Let's take a look at it. So here is the beginning of that. That's the opening tag, web-API, and here's the opening tag there, and these are the attributes that that provide additional information that's useful for the application in interpreting this information. And this is the closing tag, and this is the contents of the element, the web app element. We have we have two sub-elements, servlet and servlet mapping. Each of these sub-elements have their own sub-elements. And here's the newsfeed servlet being referenced inside this deployment descriptor. That's what the web.xml file is called, a deployment descriptor. Here's our newsfeed servlet being referenced. This class is associated with this name. In fact, what happens is Tomcat creates an instance of that class and lets us refer to that instance through this name. And now, rather than letting request for news.rss to pass through to that static file that we had previously, we're telling Tomcat that we want requests for this URL to be satisfied by our newsfeed servlet. So we provide that name, and that's the name that's connected to an instance of this class. Alright, so there's our web.xml file. Let's take a look. We haven't talked about it, although it's written up in the book, that when a request for news.rss comes in, this method will run. And as you can see here, it starts to build the response. Alright, all this information in here will be part of the response. And finally we come down to the bottom here and send the response into the output stream, and we're done. So without getting into the details there, which you need to do, well, that is done. Okay, let's see what the next step is testing. Actually, we're at the moment for the test. I'm going to clean up my log files, delete those first, and I'll go into the bin folder and start up Tomcat, which is this batch file right here. I'll just keep an eye on the logging output. Looks good. And let's go ahead and take a look. Oh, wait a minute. Oh, that's right. It is deployed already, isn't it? Let's go ahead and check this. And there is an error. Oh, look at this. Communications link failure. So, servlet exception. com.mysql.jdbc.exceptions.jdbc4.communications exception. And if you look in here, look, here's our publisher.web.newsfeed servlet do-get. So this is in fact the method, our do-get method, through a servlet exception. Let's take a look at that. Here's our do-get method. As you can see, it's declared as throwing a servlet exception. So there's a connection right there. And in fact, this I believe that this is where it happens. This is where we throw the servlet exception, and we're wrapping an SQL exception that was thrown by calling getConnection. Let's take a look at that. And there it is. This is called the root cause. And you can see in here that at some point we called getConnection right there. We're inside, see this publisher.web.newsfeed servlet do-get. So in here that this code inside do-get in fact invoked get connection on this driver manager, and that we see that here. Here's the do-get method, and it calls get connection on driver manager. So you can see what's called the stack trace. And so this exception, which we threw it because we wrapped it. We wrapped that exception. When this get connection actually threw an exception, that calling get connection here is done inside this try block. When we catch that exception there, what we do, the exception is of type SQL exception. What we do is that exception here, E, we pass it into a servlet exception and throw that out. It's because we can't throw an SQL exception directly from do-get, because we would need to modify the function's signature, which we're not allowed to do because we're overriding a parent. So I had to place the exception either in here, or throw an unchecked exception. That's the other way to do it. And we just put it in there as a servlet exception. It gets reported to us in any case. But it's pretty straightforward. Look, it can't connect to the database. Well, we're not running the database. So in fact, that's what we need to do. But I must have skipped over a lot of information here. Let's see. What else did I not do here? So here we make this connection, and I think I need to put some code in here actually. Oh, here it is. So in the and we'll look inside this code. So here's the connection we're making to the database. This is the URL that tells the system how to find the database. Database is running on local host. The name of the database is publisher. This here will be the database username publisher, and this is the password for the publisher user, which is also password. I set those all to the same name to make it easy to remember. And so this, I believe that we have already created a database called publisher with a username publisher as well. So let's test that. But we need to start the database. Let's go ahead and do that. So I'm going to go into look at MySQL. It's in Program Files. I think it's under Oracle now. Nope. It's under somewhere. Where is it? There it is. MySQL. Let's start it up. That one right there. Error. What is going on there? Let's see. MySQL D. It's the wrong one. That's a command line client. Let's get this one going. D is for daemon. In other words, it's a service. Let's try this one more time. We started the database. Let's go ahead and reload this. There we go. That's it right there. If we view source, see, Chrome doesn't present this information very nicely, but if we view the source, we'll see that it is in fact, it's not a web page, it's an XML document. And there it is, my local news feed, localhost, publisher. This feed was created using Rome. This is all of our text that we generated. So we're making a connection to the database actually, but we're not. Do we get anything out of the database? Yes, we do, don't we? So I forgot that from the last lesson we actually went into the database to add records. In fact, that's what we're doing, is displaying those right here. So if we go into the database, you'll see that these records are from the database. Just to tie this whole thing together, we should look in the database quickly just to see where the data is coming from. And I'll go into the command prompt, run MySQL -u publisher -p publisher -d publisher. That brings us right into that database. I'll do show tables. There's the news item. Let's select star from news item. There it is. CNN, the link. Fox News, the link. As you can see in the news feed, we have CNN and Fox News with their links. Alright, that's it for this chapter.